Tom, I'm
Howdy.
Dominique.
Good.
How are you?
I'm doing good. How are you?
Okay, nice and toasty.
It is very nice.
Yes.
So
Okay,
thanks
good.
for offering this up. It's really been interesting putting this together to talk to other people about.
Uh-huh. Yeah, all our speakers have said the same thing. It's a kind of talk that people don't do necessarily, both science and art. So it's really fun to see what people come up with.
Well, and it's actually quite an argument discussion in this community as well, with amateur astronomers. You know, are we doing pretty pictures? Are we doing science? You shouldn't do this. You should do that. And sometimes it gets, well, as you can imagine, on the internet.
Yeah, oh yeah, for sure. And so people are usually, so earlier in, hello everybody, I'm Dominique Bachelet. I'm from the Biological and Ecological Engineering Department. And earlier in 2021, I organized a series of talks by scientists on the positive aspect of climate change in order to inspire artists to submit an art piece to a fall show at the Corvallis Art Center entitled, "What Will Nature Do?" Submissions are requested by July 1st, and the exhibit will take place September 30th to November 13th at the center. All the seminars were recorded and made available on the center website. This particular series of talks this term, co-sponsored by the OSU ArtSci group, led by Dr. Jerry Bartholomew, the Corvallis Art Center, and the Department of Biological and Ecological Engineering, is by scientists who are also artists and artists who are also scientists, with the goal to explore how their science might inform their art or their art might inform their science. It is my pleasure to introduce today Dr. Tom Carrico, who has been involved in astronomy for over 40 years and astrophotography for the last 30. He retired from Hewlett-Packard in 2015 after 33 years in various engineering and management positions. Tom currently teaches astrophotography in the Honors College and physics. His astrophotography has been published in numerous magazines and books, exhibited in local galleries, as well as being featured on OPB's Oregon Field Guide. For the 2017 Great American Eclipse, Tom delivered over 60 talks to more than 5,000 people, emphasizing eclipse viewing safety and enjoyment, as well as photography. He continues to practice astrophotography from his yard in Corvallis, Oregon, and from a remote-controlled observatory in New Mexico, allowing him to image the universe year-round. So, Tom, it's a great pleasure for me to have you give a talk in our seminar series. Thank you very much for participating, and the floor is yours.
All right, so I need to be able to share a screen. Okay. Well, thanks so much for having me around. I do have to mention one thing about the eclipse now that you mentioned that, and that is we did emphasize eclipse safety. And after the eclipse, I went to my eye doctor and I said, how many people came in complaining of eye problems? And she said none. And that was probably one of my proudest moments of the eclipse. Is I think I saved people by having a lot of talks about that. All right, so I was very excited when I was asked to put this together, partly because I've been called many things in my life, a nerd, a geek, and a lot of other stuff. I'm not sure I've ever been called an artist. So I'm going to take this opportunity to kind of give my definition of art, how it applies to the astrophotography that I do. And then, I don't know, I kind of will answer this question, is it art or is it physics? But I hope to lead you kind of on my journey over the last 40 years and let you think about it as well. Now, if you have any questions, I don't mind if you interrupt, or we can just talk about it at the end. Either way is just fine with me. So way back when I started, and as was mentioned, I've been doing this for 40 years. You know, I started when I was 4. I had no idea what I'd be taking pictures of, but I was pretty sure it wouldn't be of objects like this. I had this idea that it would be galaxies and clusters and things that science needed to know about, because certainly by the time I'm this age, we would be traveling in our spaceships out there. So a little bit of disappointment there, but I still allow myself to go out and think that, well, maybe someday we'll get there. Now, when I take all of my images, even from the start, I did think a little bit about, well, what am I doing here? Am I just taking images as a result of putting together all sorts of real cool gear, or am I trying to create something? And in this talk, I'll talk a little bit about how that's changed over the last 10 or 15 years, and how I've severely modified what I do and how I do it. And I'll talk more about all these images as we go along. So this is it. This is my journey in astrophotography, starting from when I was, I'll call it a kid, until today. And hopefully you'll get a good idea of kind of physics versus art in all of this. So some people really don't understand what's astrophotography, right? I mean, they kind of get astronomy and they understand, oh, that's looking through a telescope, but it's a little bit different than that. So when I hear astrophotography, I really go right to this photo. This is where I do everything. This is my control center up in my room upstairs. I've got a computer that's connected to multiple computers in my yard, at other places around the world. And I'm kind of hunkered over the keyboard with my Dr. Pepper M&Ms and Oreos, taking photos. And to some folks, that could be kind of a very mechanical, weird process. To an engineer, it's really nothing just short of perfection. Once I take the photos, once I've gathered them, then that's only half the job. I then need to actually put them together. I have to process them. I have to make them look the way I want them to be. And that's kind of where the controversy is the way I want them to be, the way they should really be represented. Do I post it on the internet? Do I share it with my friends? Do I print it? Those are all things that I think about every time I take an image. Some images don't lend themselves well to printing at all. Some are far better just to see on a nicely lit screen. And then once I'm done, it's on to the next set of objects. And it turns out, there's like a few thousand objects in the night sky, maybe a few million. So I'm not going to run out of anything to take pictures of. And I do go back and revisit them depending on my skill level and just what it is I'm trying to accomplish. But the real question is that came up when I got this invitation was, what am I really trying to do? And I had to be honest with myself and think, this has changed over time, and I still don't have the perfect answer to it, but we'll get somewhere along the line, and maybe you can all chime in and help me. So my ponderings on what is art and what is physics, and this is coming from someone that's been an engineer their whole life, so you'll have to excuse that a little bit. So art, I actually looked it up on the internet and spent an hour or two looking at all the definitions. I thought Leo Tolstoy actually had a very interesting definition, but it boiled down to me that it's something that's personally created. I mean, with the emphasis on created, that it evokes some kind of thought or emotion. At least that's what it does for me. If I think about it, if it changes the way I have a viewpoint or anything like that, it's probably art. And that the meaning could be subjective. It doesn't mean the same things to all people. And that's true in astrophotography as well. Now, physics. So I love physics. And before I go on, this is one of the few pictures that has the moon in it that I really like. This is Ansel Adams' Moon Over Half Dome. Absolutely a wonderful artistic piece. And every time I see it, I kind of wish I could be there. And I think it's wonderful. And it's compelling, emotional, all the things that make art really great. And I even, like I said, I like the moon. If you take any of my classes, you'll realize that I really don't like the moon, but in this picture, it works. Now, physics, what physics just is, right? It's everywhere. There's nothing we can do about it. I can't fight the law of gravity or the speed of light or nuclear fusion. It just goes. Here's Britannica. Even the definition of physics is kind of harsh and in your face. And that's the way it is, but I like it because it's somewhat linear. There's bounds. It's easy to define, and it's kind of hard to argue with. Kind of as an aside, nearly every engineering class I took in college started out with Maxwell's equations, and they said, if you understand this, you're not going to have any problem with the class. I never ran into anybody that understood it, so we all had fun and issues with all of our classes. And it's true with astrophotography. If you can really figure out what all those 4 equations mean, the rest of this talk is going to be trivially easy. Okay, so the first thing I thought about when I put this together was I always have some kind of astronomical background on my slides, and I put a little thought into them. Do I want to make it a nebula? Do I want to make it the last picture I took? And I decided that I wanted to use this particular picture, and here's what it looks like in regular without being put in the background of PowerPoint. It's a picture of 2 globular clusters that orbit our galaxy. They're about 40,000 light years away, and each one has somewhere around 100,000 stars in it. And I just love how they hang there. I've been trying to take this picture for a number of years. I kind of never got around to it. I just think it's a lovely picture. I like that it's black and white, and it's pretty cool. Now, anytime I take a picture like this, along with getting the 2 main subjects in there, on the lower right, that's Messier 53, discovered by Charles Messier in the late 1700s, and in the upper right is NGC 5053, and that was discovered by Herschel, also in the late 1700s. When I take a look at these, I look for other things in the field of view. And so if you look over here to the left, you see, well, those are some galaxies. So these stars, all the stars are in our galaxy. They're a few thousand light years away. These objects here are 30 or 40,000 light years away. And that object is, 10 to 50 million light years away. And I don't mean to throw out that as a small number. I mean, light years are gigantic. So I typically look around to see if there's anything else interesting in my field of view. Maybe I caught an asteroid, maybe there's a really faint galaxy, maybe there's something else going on. And I spent a little bit of time scouring, and this one kind of took my breath away. Oh, also, this is the way I love to have astronomers describe these things, right? This isn't just a group of stars in a globular cluster. It's a gemstone inside a tiny jeweled chest, which is encased inside a larger jeweled chest. That's how I want to describe stars. I've also heard it described as diamonds on black velvet. But the compelling thing about this image to me is this. So down in the lower right, you see the very edge of the globular cluster that was in the lower right. And at the intersection of those 2 red lines, you should see a faint elongated fuzzy. So galaxies are often called faint fuzzies. That is a galaxy pretty far away, and it has a catalog number that's like 8 digits long. I don't even remember what it is. But I have a number of star charts and catalogs that I go to find out more about it. And I go, I bet you that one's pretty far away. Well, it turns out that that galaxy is 4.3 billion light years away. So the light from that galaxy left just as our solar system was being formed. I mean, the Earth really wasn't even in the consideration at that point in time, but that galaxy was shining and sending photons our way. And after 4.3 billion years, the light went through my telescope and hit my detector. And I just think that that is just amazingly cool. And it makes me feel like I'm participating in the universe. And that's why I love astronomy and astrophotography. So I think it's cool from a physics point of view, and I think it's cool from the kind of things that it makes me think about. Now we move on to the sun, and here's the thing, that all astrophotographers, we don't like the moon and we don't like the sun at all because it keeps us from viewing the night sky. But every once in a while we take a picture of it because it's kind of interesting, and then we think about all the cold hard science behind it. So this is our sun, and some of you may recognize this exact image, and I'm not going to give it away just yet. But just some facts about the sun. It's 860,000 miles across. You could stack 109 Earths from top to bottom, and you could fit 1.3 million Earths inside. It consumes 600 million tons of hydrogen every second to turn into helium, and then the rest turns into energy that illuminates the Earth. Those sunspots are all bigger than the Earth. So that's all the physics, and that's really great, and it's kind of neat to think about it. But what it really is a couple hours later, we had this. And so this is just, to me, I was my very first eclipse. I think a lot of you saw it back in 2017. I had no idea that this was the kind of thing that I was going to be able to experience. In my backyard, I had 5 cameras running. It was clickety click the whole time. I had videos going, and I was able to capture an image like this. And then this. I have wanted this image since I was 7, maybe even younger. And this image scientifically is just baloney. The eclipse did nothing like that. The moon didn't go across the sun in those directions. Things weren't oriented that way. It doesn't matter. This is how I've always imagined a total solar eclipse my entire life. And I had to make it so. And I really got a kick out of putting that together. It took me days of processing and fiddling and working with Julie Bradshaw to get this out and to get it printed. And it was a lot of fun. And so what it's done is it's turned me into an eclipse chaser, and I'm headed to Arkansas in 3 years. Okay, so kind of back to why astrophotography? Why not just look through your telescope? Well, so looking through telescopes is pretty darn cool. I did it a lot after I got my first telescope. I didn't look like this person. I don't have a skinny tie and white shirts that I wear with it, or loafers. But looking through a telescope is a lot of fun, and I highly recommend all of you do it because you can see a lot of neat things. But the problem with that is you really need dark skies, really, really dark skies. You have to go out to the desert, something like that. Your eyes also don't see color at low levels of light. So everything that I'm showing you here today, all that color and all that beautiful stuff, it's accurate, but your eyes will never see it through a telescope. Even if you had like, a 200-inch telescope, it doesn't work that way. So we're kind of doomed to always seeing just shades of gray in an eyepiece. And finally, well, it's cold. It's not like skiing where it's cold outside and you're running around and jumping up and down. You're standing outside, probably in wet grass. It's probably humid. There's mosquitoes. And even on a nice summer's night, by the time it's 1 in the morning, it's 50 degrees and it's cold, and you're wondering, why aren't you an astrophotographer so you can be doing this from inside? So for me, this all changed when I was just a few years ago. So this is me back in 1986, and that is my very first telescope. And one thing that's important is if you look at that telescope, there's only one wire going into it. And this was when I lived down in Silicon Valley. And if you're familiar with the area, I grew up in Sunnyvale, and I'm at Stevens Creek Dam. So this was a pretty dark place that you could go to that's just a few miles out of town. And the reason we went there is that the guy leaning on me right there said, Tom, he actually called me something else, but we've got to go take a picture of Halley's Comet. And so that's not the first photo of Halley's Comet. It's my first photo of Halley's Comet. I was hooked on photography once I took that picture. I just thought, wow, look at that. I could see the tail, because even while we were at a dark site, you couldn't see too much. It was wonderful. I go, I have to do more. So I went home a couple months later and did some more research on how to do photography. And I took this photo. And this is called the North American Nebula because, well, it looks like North America. And I saw color. I mean, look at it, it's red. And the background is, kind of dark and maybe a little blue. And this was taken with film, right? It's just a horrible medium for taking pictures. I'm glad it's gone. But at that point on, I started gathering up the eyepieces for my telescope, and I just put them aside. And for the most part, since 1986, I have rarely looked through a telescope compared to the amount of time I spend on astrophotography. So that's why I do astrophotography. It absolutely opens up the rest of the universe, because there's color now, and I'm in more control of what it is that I can image. So that's why I do it. Now, it's a lot of fun. If you're an engineer, there's nothing better, or worse than astrophotography, right? And so, you have to keep at it. I've been doing it for 35 years. I think the longest I've gone in a row is about 15 nights without something breaking. So, you really have to be persistent and want to keep going. Alexander the Great is true, because sometimes it does seem it's impossible that getting anything done. But my favorite quote, and I use this at work all the time, is that the universe is not unfair. It is simply not interested. So there's nights when I'm out there and things aren't going well, and I'm wondering why the world and the universe is conspiring And Eleanor Gates' voice is in the back of my head saying, it's not, they just don't care about you. It turns out Eleanor is an astronomer, so she knows of what she speaks. Now, when I started doing all of that stuff, and I had that little telescope that you saw in the background, I realized that, well, if I only had a better telescope or a better mount or a better camera or a better location, I'd be on the cover of Sky and Telescope or Astronomy magazine. And so this is kind of the history of all of the things that I have purchased and sold in my life. I've gotten lots of telescopes. I can see under mounts. This is the thing that moves the telescope through the sky. Twice I've owned an Astrophysics 900. I've gone through cameras, and these are all very specialized CCD cameras. I currently have 4. It's crazy. And then as far as locations, well, I do a lot still in my backyard, but I do even more down in New Mexico, California, and Arizona. It turns out these are businesses that are on a mountaintop, and they will basically give you a building with a roof that moves and power and internet, and you take your gear down there and you control it remotely. So when I started doing this 15 years ago, there were a couple, and now they're all over New Mexico, and there's some in Arizona and there's some in California. And the requirement is you have to be out in the middle of nowhere, so that keeps the land kind of cheap. It's got to be dark, and you have to have some kind of infrastructure there. And so all these places have popped up, and it's wonderful. I love it. Now, people have said, gee, Tom, this looks like it's a lot of money, and it sort of is, but this is 35 years worth of gear, and really, if you add it all up, it's less than the price of a Lexus. But that's over 35 years, so it's not too expensive of a hobby, considering you could have a boat or a car or something else. But this is where I sit today: a few telescopes, a couple of mounts, too many cameras, and I'm hosted at a place right now called Dark Skies, New Mexico. This is the gear I have. So this is the telescope that's down in New Mexico. You can see the roof, it rolls off on here. And then this is the telescope in my backyard. And notice that there's more cables, right? Compared to the one from the other telescope when I was just looking through it or taking a single picture of F. Halley's Comet. There is a competition. Whoever has the most cables wins, and I'm currently in 7th place. So anyway, these are the things that I use. They're set up right now, and I image every night that I possibly can. Now, remote astrophotography, because of things like Zoom, the software's gotten much better, and I can connect directly to a telescope down there and control it just like just as if I was sitting right there. So it works really, really well. Now, back to kind of the whole art versus science thing. I have to admit that when I started, it was all about the science and engineering. I thought that the telescopes were neat, that the mounts were neat, all the gear was pretty cool. Back in the 80s and 90s, there wasn't a lot of integration in terms of computers and everything else. And there were all these little mom and pop shops where you could buy a better focuser or buy a better lens or whatever. And I was always tinkering. And if I could get 4%, better performance, I would go out and buy it. And it was all just about the experience. And I realized that the images, they were just an outcome of the proper execution of all of my engineering. And I have no doubt of that. I would just take an image and go, okay, yeah, that one looks pretty good. Let's go try something else. But this time I'm going to have a different mount, or this time I'm going to expose a different way, or this time I'm going to do whatever. And I would just churn out images, and maybe 10 or 15 a month. And I'd say, those look pretty cool, and I'd post them on the web or wherever we did back in the 90s. And you'd get some comment, looks great, you need more work, whatever. But that wasn't what was critical. And that changed. But before that, I wanted to just kind of show you the things that were really important to me. So you really wanted to have the absolute best focus. You wanted to focus your stars to the point that they were so small that they were nearly invisible. And so people judged you on your focus. They would look at an image like this and they go, wow, look at those stars. They are so tiny. What a great job. And they would kind of lose sight of, that's the Horsehead Nebula, one of the most iconic images of all time. In fact, this particular image, another bucket list image, if you watch cheesy science fiction movies, little Timmy will ride up to the observatory because he thought he saw a Martian landing or his parents had been taken over. and he'll run in and he'll see the astronomer in a white coat with an unlit pipe. And in the background on the wall, there'll be a picture of the Horsehead Nebula, because everybody knows that. I think there's also one on the Starship Enterprise. So that's one thing we were trying to do. The next thing was, we want the stars to be round. If the stars are round, that means that your telescope and mount are operating properly. I spent so much time working on this. I wrote software so that you could monitor your mount. Thousands of people downloaded it to help them get round stars. On the internet, I wasn't known as Tom Carrico. I was known as Round Stars. And again, kind of lost sight of what I was taking pictures of, but my stars were round, and that was really pretty cool. I mean, it got so bad that I would actually get these images ready and I would stare at them like this, and I was done. So awful. Then the next thing was deep exposures. Could you capture it? Could you see the smallest possible detail? Could you see the faintest possible nebula? And you would look at a picture like this and go, wow, look at this dark nebula over here. You really got the contrast right. So you're kind of getting a theme here that really, it didn't matter what we were taking a picture of. We really couldn't see the forest for all of the trees. And then finally, and this still goes on today, it was the pursuit of the weird objects, right? So, 30 years ago, there was no internet. There was only magazines and books, and you would find something in a book and say, oh, I want to take a picture of that. So one day I was looking at something and I said, oh, that's pretty cool. Yeah, that's Sauron's eye. Well, it turns out not too far away was Sauron's other eye. And I just thought, oh, that's clever. And I posted it and got a grin out of it. And I didn't really think about what it was that I've captured here. One, these exposures are insanely long. But now when I look at them, I think about, these are the remnants of stars that blew up or shed gas. And this is part of the natural life cycle. And I like that a lot more than I ever used to. So I did all this stuff to make the engineering good. And that was kind of tough. But I grew up. I got smarter. I got wisdom, all those good things. And this happened probably 15 years ago or so. And I've got an image I'll show you, the one that really kind of put me over the edge. But ultimately, the image became the goal. I realized that chasing, the absolute best focus and all that, that's not really what I'm after. That's not really what I want to leave my children and my wife and all that kind of stuff. I want to do some other things. And so I also want to be accurate. I want my colors to be right. I want the representation of the star brightness to be correct. I want it to ultimately kind of be like art. And then I changed from trying to take 150 images a year to the point today, I probably take 15. It probably takes me 3 to 4 weeks of data capture over multiple nights to get enough data to get enough images so that I have, a great signal noise and an image that I can be very proud of. And so I feel like it's a bit of maturity on my part. And what it meant was I had to be patient. So I had to say, okay, this is the first image in a long journey of a picture that took me 2 months to gather the data for. So this is a 10-minute exposure through a blue filter of what ended up being this. And this is one of my favorite pictures. So this is called the Ghost Nebula. Astronomers aren't really creative in terms of their names. Or, there's the Batman Nebula up there. I never thought that I would take images like this, and I never would have until I took a step back and said, what is it that I really want to do? And this is, I just love this image because all we're really seeing is dust. There's not a lot of, primordial gas or anything like that. This is just weird dust that's out there. And there's a few places where you can see, kind of the rest of the universe behind it. But for the most part, really, this is just kind of what's going on in the rest of the universe. And like I said, this is 40 hours of data. And to actually get that, I had to throw away a lot. And I spent a better part of 6 months working on the processing, starting over and creating and making sure I had it. And to guide me was really the physics, because I didn't want the colors to look too weird. I didn't want them to be saturated. I didn't want them to be too red or whatever. So I was constantly having to check myself against what I knew were, the correct star colors and things like that. So just kind of give you a better idea of how this all works together. So there's the scene, which is how nice is the sky. If it's twinkling, no one's taking astrophotography. And this brought up a saying for me: never go to bed on a perfect night of seeing, call in well, or retire. And that's probably one of the reasons I retired. You can have a great scene, but if it's foggy out, you're not going to get anything done. We spend all this money on everything. We still have to track and guide the stars perfectly. And that's a big engineering feat. We have to stay in focus. I mean, this is a big, huge piece of metal. The focus changes with temperature. You have to stay on top of that. We have to capture lots of data. Then we have to be brutal about what we keep. And then we have to process it. And in the end, we have the final image. So in the old days, I was all about the blue. That's all I did. I cared about that. And, an image popped out. But today, I don't start anything until I have an idea of what is it that I'm trying to do. And that guides everything up above. So I've gone from science and engineering being the dominant force in my astrophotography life to this is what I want to take a picture of. This is the Veil Nebula. This is a star that blew up 30,000 years ago. And it's so cool that if you take a picture every 10 years and lay it on top of each other, you can actually see the nebula is still expanding. And I think that kind of stuff is just amazing. So a very pretty picture, but also, indicative of what's going on in the whole universe. Now, one question I get asked a lot is those colors, how can they be right? How do you know that they're right? Well, we spend a lot of time working on that. And the way we do it is the sensors in these cameras we use are monochrome, they're black and white. And so we have filters that we put in front of them. And then we take a picture using a monochrome sensor through a red, green, and blue filter and put it all together. And that's all thanks to James Clerk Maxwell way back in the late 1800s. He's the one that figured that out. So here is the spectrum of visible light that our eyeballs can see. And these are the band passes of the filters. So red, green, and blue, it's pretty straightforward. And all I do is I expose through each filter, and then I create master images in red, green, and blue, and I tell the computer combine them, and I get color. And I'll show you an example of that in just a minute. PixInsight is the software that we use, and I've got a quick example of that as well. So the calibration part, well, you find a star that has the same spectrum as our sun. So if you're a fan of the original Star Trek, the Enterprise would go into orbit around a planet, and Spock would turn to Kirk and say, "We are now in orbit around an Earth-like planet that orbits a G2 star." Well, our star is G2 in color. That's the code name for the spectrum. And so what we would do is, in your image, you would look for a G2 star that had been cataloged by some observatory somewhere. And you would take a picture of that and figure out what the exact parameters were and apply that. And it was a huge engineering effort, and it was fraught with peril, but it kind of got you accurate color. That's the old way. Today, we just go to some of the big observatories. They have pictures of everything. And what they can do is they can say, here's all the color and all the stars that are in your picture. Here's your calibration coefficients, and you're done. So now everything is way better. And it's very easy now to get exactly the right color for everything. So when I take red, green, and blue images, I am very sure that my star color is spot on. Oh, so this is another one of my favorite objects. This is called the Rosette Nebula. And this is in the constellation Monoceros, which was created in the late 1600s because there was a hole in the sky next to Orion. And I love this picture. It does look like a rose, but not to me, because like I said, I've not been called an artist. I've been called a nerd and a geek. When I see this picture, I see this. This is from the original series of Star Trek. This is the Guardian and the City on the Edge of Forever, which is arguably the best episode of all of Star Trek. So there's the Guardian. There's the Rosette. See the resemblance? So now you can never unsee it. All right, so this is the whole process, and I'm not going to go through all this. That's just too long. But we take a whole bunch of calibration frames. We take a whole bunch of other frames. We get a lot of frames that have been calibrated, and then we have to go and do some processing with those. So we take multiple exposures, and people ask me this all the time. Why can't I take an exposure that's like 5 hours long? And I could, but I can guarantee that at 4 hours and 59 minutes, the neighborhood cat's going to jump on the scope and wiggle it. And now I have to throw away a 5-hour exposure. Or planes go through it, or birds do things on your lenses, or all sorts of things can happen and you lose all that time. So it's better to take shorter exposures. And if something goes wrong, you only lose a few minutes. And just to give an example of why we stack up a lot of images. So here's a 90-second image of part of the sky. Here's what it looks like when I take 4 90-second images. It looks a little better, right? Here I am at 16 images. I can start to see color, and then finally at 90 images. So I could take one image that's 90 times 90 seconds, 8,100 seconds, but like I said, I run the risk of losing the whole image if something funny happens. If something funny happens with taking 90-second exposures, I lose one 90-second exposure. And this, again, compare that to one. So this 90 image of 90 seconds is the equivalent almost of 8,100 seconds compared to the 190-second exposure. So that's why we stack up, because it gives us the equivalent of a long image. So kind of back to the whole calibration thing here. Once we've got all of our light images, I need to line them up, combine them into separate images, and now I'm ready to process. Now, all of this happens automatically with the computer. In the old days with film, you took a picture and that was it, you were done. And so it's so much easier today. We just let it run and computers, grind this through all night long. So, so this is my cat, and she keeps me honest all night long. This is just kind of a picture to show you that I'm connected to a computer down in New Mexico, and I'm processing data down there, and I'm connected to a computer in my backyard and processing data there. I think the cat thinks the picture's of her, but really it's not. Okay, so let me just walk you through kind of how we put all that together real quick. This is a single 10-minute exposure of the Cocoon Nebula through a red filter. And here is a single exposure through a green filter and through blue. And then I take 18 of each and I stack them all up. And so here is now the equivalent of 3 hours of exposure in red and 3 hours of exposure in green. So red, green, maybe you can see what this is going to look like. And then here's 3 hours in blue. Then a miracle occurs, sort of. What we have to do is you have to go in and make sure everything is calibrated and lined up, and that all works great. This is PixInsight. This is a software that literally every astrophotographer on the planet owns. It's absolutely won the war for image processing. Everybody uses it. It's wonderful. And you end up with the Cocoon Nebula. This is another one of my favorite images. It looks like the nebula just rolled through the stars and moved them out of the way. And you can see, remember how bright the red image was right there, right? And then we've got a little bit of blue on the outside and all of the stars. And this image has been perfectly calibrated. These star colors are just right on. You can see there's some orange and blue. If you ever see a green star in an image, somebody messed up because there are no green stars in nature. Now, this is the image that turned me from being all about engineering into all about art. For a couple of years, I had access to a big telescope, a 13-inch. And so I took this image with it. And I was just absolutely blown away at what I could see and just how beautiful it could look. And I could see, the red star forming images. I could see, these wonderful spiral arms that have been disturbed by some other galaxy. And I just looked at that and I stared at this image for an hour after I took at it because I just could not get over just how amazing it looked and what it meant to me as an astrophotographer and as a person. This was kind of the turning point image. One last thing before we wrap it up here. We've got the red, green, and blue, and that's all for getting accurate colors and making sure the purists are happy. But there's also very specialized filters, and this is what the Hubble telescope has. They're very narrow band. This one is centered on oxygen, hydrogen, sulfur. So what those elements emit are all that is let through. And what that allows you to do is to take an image like this. So this is what the Crescent Nebula or the Jellyfish Nebula looks like when you process it perfectly with the red, green, and blue. And you can even see just a hint out here of teal. But if I use filters that are tuned to the wavelengths of the elements that are actually there, I get this. And I love this image because if you look at it, you can see that the green, which is oxygen, has enveloped the hydrogen that's on the inside. And so that tells me a lot about what happened from a physics point of view, but I just love how this turned out, that this is one thing inside of another. It's beautiful. And now we can see all the hydrogen gas out here. We can see the oxygen in here. It allows me to basically see so much more than I could from just looking at a red dominated image. And if I want, I can change the color to anything I want. And this is what's so fun about narrowband filters. no one could accuse you of having the wrong color because by definition, they're the wrong colors. In this picture, I made the hydrogen look like beaver orange, and I made the oxygen look like blue. If I'm in a more holiday mood, I can make things kind of red and green. This is the Veil Nebula. That's the one I showed you earlier where the stars blew up. So kind of, gotten through all that now. So today, where am I? Well, it turns out amateur astrophotographers, they can do science. And every once in a while, us amateurs do discover something. We discover a new nebula. We discover comets and asteroids that are missed by all the automated surveys. We do join in on a lot of professional collaborations to basically provide a lot of data. Sometimes they'll ask us, we need every astronomer to point their telescope at this star and take a measurement. And that way the professionals get like 10,000 observations. So that kind of stuff happens and it's great and it's wonderful. But what I have learned, and I'm in contact with an awful lot of amateur astrophotographers, is most of us do this because it really ends up to us as being art, right? They've got their own interpretation of what it looks like. They want to print it, they want to post it. But in the end, as you talk to them about their images, they're very inspired by what they've done. So now, what's my mission with all of this? Well, I teach. I have so much fun teaching at the Honors College in physics at OSU. These are pictures that were just taken in the last couple of weeks by students in the classes. So they have access to the telescopes down in New Mexico. They learn how to take the photos. They learn what's going on. They learn about the physics and about the art. And it's great because a lot of the students that are doing this, they are not anywhere close to science majors. And it's so fun getting their interpretation of what's going on. It's really expanded my view of the universe. I do a ton of outreach. With COVID, we used to, before COVID, we had star parties and people would show up with telescopes and we do all these wonderful things. But now we do these virtual star parties where people do exactly what you're doing right now. You join me and I'd be connected to my telescope. We would do it at night and I would show them pictures like this in real time. And what has absolutely blown me away is we continue to get people after 15 months of doing this. We just had one on Friday night. We had 26 people show up. So people are genuinely interested in this and learning about what's going on. And then finally, I have created a group called the Northwest Astrophotographers Group. We have 30 members. It's people in the Willamette Valley and it's starting to grow. And the purpose of this is to share everybody's experience in astrophotography and also to bring in people that have no idea how this works and educate them on how to become astrophotographers. So this has been a very fulfilling thing for me because, as a person that started it and founded it, I get to see everything that's going on. I get to see all the messages going back and forth and manage kind of who's working on what. It's just been outstanding. And my involvement in astrophotography has increased tremendously with all these different viewpoints and the things that they're trying to do. So just kind of, I also don't lose sight of my objective, which is this kind of stuff. Another iconic image, Messier 104. This is a picture it took me 20 years to get. Every time I took it, something happened. Every amateur astrophotographer wants to take a picture of the Horsehead. You saw it earlier in black and white, but it sits in Orion's belt. Wonderful picture of Orion's belt. And then finally, this, to me, another just amazing image of what's going on in the universe. The blue is kind of dust, the red is hydrogen. There's just all sorts of weird things going on there. Every time I look at this, I think of space battles and science fiction books I read when I was a little kid. And it just keeps bringing me back to the awe and mystery of the universe. So my answer to the question, astrophotography, is it physics or science or art? It really is art, because to me still it's all about the emotion and the thinking and the ties that I have back to the astronomers from 200, 300 years ago that were struggling to see anything, and what I'm able to do because of all the work that they did. So there you have it. There's my answer to the question. If you have any questions, ask the cat.
Thank you, Tom. That was a great presentation. Beautiful photos. Oh, my Lord. It's really fantastic. Yeah.
And I should mention just one other thing. I do have a site. I'll put it in the chat here. a place where I put the images that I'm most proud of. And if I quickly share my desktop there. So this is a site called Astrobin, and these are images that I have done over the last few years. And so you can click on them and zoom in. For example, this was the picture I showed earlier, the Lions Nebula. And so there's kind of a bigger picture of it. But it's a place where you can go just to see kind of the stuff that I'm up to.
Cool.
And if you're just interested in it, I add to it a couple of times a month. And like I said, the pace of pictures has gone down a lot because I'm really now more interested in making something meaningful.
Yeah, gorgeous. Gorgeous, gorgeous. Okay, I haven't seen a photo, a question yet. I'm curious, in your group of astrophotographers, Northwest astrophotographer, what's the range of age, and and are there as many girls as boys? How does that work?
So I would say that it's still probably people like me. I would say of the 30 people, 20 are old guys that are getting into the hobby. But what is nice is there are 3 or 4 couples that show up where it's a husband and wife team where they're very interested. This is the hobby that they want to do in their retirement. I guess it is sort of an expensive hobby, so that you don't see a lot of kids. But just before the pandemic, I would say the year before the pandemic, when we used to meet in person, in our astronomy club, we did a lot of work on outreach to try and get students coming. And we started to see a huge uptick in students showing up, just trying to learn what astronomy is and telescopes and all that kind of stuff. So, for 20 years, all we saw were people like older people like me, but it looked like there was going to be a lot more interest from students, and I thought that was great.
Yeah. Yeah. So how much does your for a beginner astrophotographer, what's the first price of some sort of?
Well, so in the class, we just do, let's see, so you can see I've just got a camera on a tripod.
Yeah.
And before COVID, we would just go out somewhere and take a picture, point it up at the night sky, and do constellation work and all of that.
Yeah.
So the price of admission is a tripod and a camera, and at OSU you can go borrow one from SMS, so it's pretty inexpensive. Okay. Or you can buy that. If you want to go to the next step and do some astrophotography where you're tracking, then you use a device like this, and those are everything you see here is probably on the order of about $1,000.
Okay.
But the thing is, it'll last you the rest of your life. You could never exhaust what you can do with that. So it's kind of cool to see that the prices of the mounts and cameras have dropped a lot in the last 20 years.
So how many photos do you frame, and how many photos do you have on your walls at home?
So I've probably framed about 20 or so. The thing that's difficult about them is, like the picture in your background, right? Mountains and trees, people kind of know what they look like when they want to print them, right? And it's easy to kind of take that image and get it out and make it look good. When I go to any kind of a shop where I want to print it and say, print the Rosette Nebula I've got here, they just look at me like, I don't know how to do that. Look at all the black that's going to come out. And so it often takes 3 or 4 iterations of printing to get something right, because it's just so weird. I used to do a lot of mail order stuff and they could never get it right. I've had some help at OSU with Julie Bradshaw again. And she's helped me with getting a lot of the prints out with some of the, I think there's an 11 color Epson printer that we've used. And so that's probably the best way to do it. But it's tough because, these are not your regular daylight photos.
For sure. So Carrie wants to ask you a question. So I told her she can unmute herself.
Thanks for the presentation. It's just very what you've been able to share with us, and your enthusiasm for your work is clear. It comes through very clearly. Thank you. I actually had two quick questions, I think. First of all, I'd love to hear more about when and where or how to join these virtual star parties. That sounds delightful. And secondly, I'm wondering if you ever take pictures of planets as well.
So the star parties, I've been working with Corvallis Parks and Rec, and so I can post a link here. We've been doing one a month, and so the next one is June 25th, and you can just register here. So I'll put that into chat. And so what I like about it is they do a lot of publicity for it. I mean, they're why we get in between 20 and 50 people. We've had up to 80 at some of them. In the summer, it's kind of tough because they don't start until 9 or 10 o'clock because it's, summer. But anyway, that's a good place to start. And then the other thing is our club website, hvaastronomy.com, you can send an email to that and get on the mailing list for all of our all the virtual star parties. But that's right there is a very good place to start.
Thank you.
And then the next one, the planets. So the planets is fascinating. They are really hard to take pictures of really, really well. Planets are small. When you look up most of my images, they are probably anywhere between twice the size of the full moon to maybe a quarter the size of the full moon. Planets are less than a tenth the size of the full moon. So you need a really long focal length telescope, and you need some specialized video equipment to take the images. And so I played with it and I've tried, and I just decided that's what the internet's for. And so I go out on the internet and look at the images there, because it's a completely different type of astrophotography. Planets are bright. You don't need to take long exposures. But when you go and see some of what the experts can do, they'll take like 10,000 exposures over 5 minutes. And then they have software that'll look at just like the best 200 and combine them. And then they've got all this very special image processing to sharpen it up. And it's amazingly complicated to get some of these images. And I think that they rival what NASA beams back, but it has not been that interesting to me.
Thank you.
Cynthia has a question. Cynthia, you can unmute yourself.
I have barky and squeaky dogs here. I was going to try to type it. But Tom, I was just curious to know how much creative license other astrophotographers allow one to use when they're sharing their prints. And if somebody kind of goes crazy with something, do people still show those, or is there a place for the more, shall we say, creative and or not accurate images to be shared?
As you know, the internet is a very well-behaved environment, and people keep their opinions to themselves. So it's this thing that the pretty picture debate has been going on for 20 years. And, so what I tell my students is there's no such thing as a wrong answer on a print. It's up to you to make the print the way that you want it to be, and it should reflect your feelings at the time that you took the picture, right? And it's been great letting them have that kind of freedom. But when you go out onto the internet and say, I'm an astrophotographer, and here is my picture of the Rosette Nebula, you are walking into a Wild West saloon and saying, who's next? And you have to have a thick skin, and people will start to argue, and they'll argue about the things that I mentioned. Are you perfectly in focus? Are your stars round? That star isn't really orange; it's a lighter shade of red, and it can get very persnickety, and there's times when it can get quite personal. And so I have kind of gotten away from posting separately on the web, and I just use that source called Astrobin. It's moderated. And so anybody that just gets completely out of hand, they're just removed. And now you tend to have discussions on, that's a great image. How did you integrate it? How long did you integrate it for? What telescope did you use? hey, you might want to try this technique in PixInsight. So it tends to be a far better environment. But if I just go post something on, I mean, there's a bunch of groups for astrophotography. It can get kind of wild and woolly and not too productive. And so a lot of people have moved away from that.
Thank you.
That's also why I like narrowband images, where I can select the color mapping, because then no one can tell you, no one can yell at you and say, that's supposed to be blue. Well, no, it's whatever I want it to be.
So how do you see the future of astrophotography? Where do you see the improvements in the future?
Well, so the thing that's going on now, and this, I gotta admit, this is tough for me because, I'm over 30, so I've kind of been around and I grew up with a certain technology and a certain way of processing and doing it. What's happening now is lower cost cameras are coming, some from China, some from the UK, they're kind of coming from all over the place, and they are absolutely outstanding. And they're like a quarter of the cost of what I'm used to. And so my original thing is, oh, they must be making some sacrifices. But the technology has gotten to the point where they have very low noise, which is the thing you're always battling when you have low light. They have very high resolution, and they've done, amazingly enough, an absolutely superior job with their software. The software just works great. And it's surprising to me because some of the old school stuff that I've been using, the software still doesn't work right? And they just use the excuse, well, we're just 4 guys in a garage. Well, the 4 guys in the garage in the UK are doing way better. And so what's happening is you're seeing a lot of people being able to get in for $1,000 or $2,000 instead of $10,000. And in the specific, the Northwest users group that I started, I would say half the people have started in the last 5 years with this low cost gear. And it's just so exciting because they're able to get truly great results really fast. And so, they're already halfway up the learning curve. And that's so encouraging because it makes you want to do more. And so I think that the state of the art is going to be pushed, pretty hard, and people are going to be able to make some just great images. And they're going to be able to do it quicker and be more satisfied a lot sooner. The telescopes, you can't make optics much better than they are. And so, I'm not too, nervous about anything changing there, but I think the rapid change we're seeing with the low cost stuff and the quality it provides is really exciting.
That's very cool. So you mentioned different countries. How involved are you with people from other countries who are also looking at the skies, but from a different perspective?
Well, this site, this Astrobin, is an amazing international site. When I post an image, I would say that 80% of the responses I get to an image are from somewhere else besides the United States. And it's fun because you get to converse with people from other countries about something that you're both very keenly interested in. I'd say half the time I have no idea where the person is from, right? And I try not to think about it, right? I mean, I just want to talk to them about astronomy. And so sometimes it comes up, that, we're from, somewhere down in South America, or we're from China, or we're from, Indonesia or whatever, right? And that's kind of fun because you think, oh, well, where could they be imaging from? Can I go there? Kind of thing. So it's fun to see the international stuff growing. And I think part of that is from the fact that the cost barrier is just being obliterated.
Very cool. Anybody else has questions? Yes, Jan.
Here.
Yep.
Yeah, this was very, very interesting. And when I paint watercolors and acrylics, and when the first Hubble pictures came out, I thought, wow, those are beautiful. And I should maybe try to paint something from some idea of what's in one of those. But of course, I never did do it. What are artists doing with some of this information? Are you seeing anything along that line?
Yes. And so I would say, so we have a club here in Corvallis that's called Heart of the Valley, and it's kind of Corvallis, Albany, Lebanon. There's a club in Eugene, there's a club in Salem, and a big club up in Portland. I would say every club has at least 1 or 2 people that do drawings. And there's a guy, and I think he's in the Portland club. It's amazing what he can do. The paintings and drawings that he has done of all sorts of objects. But what they do is that they have templates, from eyepieces. So they'll look at an eyepiece that has a certain field of view, and they'll know exactly, the sizing for everything, and they'll draw the objects. And like one of the early objects I showed you, like the globular clusters, right? The big groups of stars, they'll have a black background and they'll paint it in white. And they'll spend literally 6 to 10 hours in front of a scope, just working through that and trying to get it as accurate as possible. And what that does is it forces them to really critically view what's going on inside, because they have to transfer what they see down to a canvas and then go back. And, so they're going back and forth a lot, and they're doing this with almost no light, right? Because they can't have a lot of light, because that'll ruin their night vision. We have a member in our club. She's a woman that's been doing this, 15 years. And I see her, she shows up with her 8-inch or 10-inch telescope, and she's got, kind of a work area. And it's just fascinating watching her, because she's an absolutely acute observer. She sees things that nobody else does, because she spends so much more time at the eyepiece and so much more time looking at each of the objects and not ruining her night vision, but also drawing these things. Amazing. So it is a big thing still. It used to be bigger, I think, if we, because it was kind of free, but now that people can do astrophotography, there's more of that. But it is absolutely not going away. People really are drawing. And I think the biggest reason they do is you see so much more when you stare at an object for 6 or 10 or 12 hours over a number of nights. You really start to pull out details that you don't get in a 5-minute view.
Sounds like scientific illustration with bad light.
Yeah. So, when we're going back to doing live star parties, you should come out to one of ours just to see what these people are doing, and take a look through an eyepiece and just see, oh, hey, I could draw that. That would be kind of neat.
I have a nephew I would like to get to one of those. He lives in Salem, so that's not too far from you.
Right. Well, and there's also a Salem club that's called Night Sky 45. And they, so if you just Google Night Sky 45, that's the Salem club. And they're always looking for more people.
Okay. When you have those pictures there, you had the thing that looked like a horse's head, and
Yes.
then there were others that you see like dark areas that look like there aren't stars or whatever in those. Does anybody know what those are?
Yeah. So at first you think, well, you'll see an area and then you see like a whole bunch of like dark dust lanes or whatever. And you think, oh, there's no stars there. But no, there are stars there. There's just a lot of dust in between. So, the universe in any given area kind of tends to be homogeneous with whatever it is around there. And so when you see like a huge star cloud and you see, basically like black voids, it's not because there's no stars there. It's because there's just thick, just actual dust, little specks of, dirt and stuff that are floating in space that are thick enough to block the starlight. And that's what the horse's head is. There's all that beautiful hydrogen gas, and in the horse head is just dust that's blocking the light from coming through.
Thank you. This was very interesting.
Definitely. Yeah. And gorgeous photos. That was pretty amazing. Thank you so much for giving this talk, Tom. This was great. I'm so glad that we asked you. This was fantastic. And so the talk is recorded and will be posted on the ArtSite website and on the Art Center website, so that all the artists who are interested will be able to access it easily.
Okay.